Hey, welcome back to our next stage of the statistical journey here. Measures of central tendency, what's that? Well, if you remember, we decided from our data set, rather than give people a whole lot of data to look at, we'd draw graphs. And here's a graph here. Hey, can we go one step further? People might want to say, well, generally, what's the middle value you get of this thing that you're measuring, this variable that you're measuring in your group of individuals? What's the middle value? What's the central come up the top here? Is there a tendency for the values to be centred around a value? And of course most people up the top here then would calculate the mean. This is the arithmetic mean, sometimes called the average. Okay, so they add all the values up and divide by how many there are. Do you remember that notation? We'll look at that again a bit later on. And they say, well, that's a good measure of the centre of the scores of this particular group, describing what's happening with our sample or our group of individuals whom we're trying to describe in some way, heights or weights or something like that. Okay, so are there any other measures of central tendency? Is the mean, which most people use, what's your average math score, etc., etc., is that the best measure of central tendency? And I've got some diagrams down here. Screen clippings this time from Pearson, so we'll have a look at those later on and just see if we can describe the centre of a group of measurements or a data set so that we've got one value to indicate to people that this is about the middle. This is what you expect. You could have high, you could have lower. Okay, well, let's go and have a look at some of this, and I think you might know a bit about this already. Okay, so here we are. Here's the mean, more precisely, the arithmetic mean. Okay, there is a geometric mean. We're not going to be covering that in this course. It's commonly called the average. And it is the sum of the data divided by the number of data. So that is pretty much what you've seen in the past. If you want your average math score for a term, you'd add up all the results, percentages, and divide by how many there were on the average, you'd say. Okay, now with the IB it's very, very important to understand the notation. So they like the sigma, as I mentioned before. Sigma means sum of. In maths we use that sigma to mean sum of, and it's a sum of all the x's, xi, from I equals 1 to n, where there's a sample size of n. We've taken n measurements, and so we're going to divide by that number. And that's pretty much what you would know about already. Now down here, just watch this one. This is what's in the information booklet that you'll have with you in exams. So this is what you'll have. So get used to this form. It says the sum from I equals 1 to n of the frequency times the score. In other words, if a score occurs more than once, you multiply it by the frequency because you've got that many lots of it. Okay, so if you had x1 up here and it occurred 3 times, you want 3 lots of x1, so it's 3x1 and then 2 lots of x2 or whatever. And down the bottom, instead of n, they've got the sum from I equals 1 to n of all the frequencies. Okay, so it might come up in a frequency table like this. Let's have a look now. We don't probably need this one over here. So let's say we have a score and a frequency. Okay, so let's say the score, let's put them in order, is 9, 10, 11, 12 or 13, and this occurs once, this occurs 3 times, occurs twice, 4 times, that occurs once. So how many scores have we actually done here? What is n? It's the sum of these frequencies, isn't it? Which is 11 in this case. Okay, so that's a total of 11 here. So n equals 11. So this is the sum of fi from I equals 1 here to 5. There are 5 scores. Okay, the sum of those frequencies is 11. Okay, so n is 11. So that's a way over here now of talking about n in a more complicated fashion. Add up all the number of times the scores occurred, and then of course if you want x bar, you've got to realise here that the 9 occurred once, so it's 1 lot of 9 plus 3 lots of 10 plus 2 lots of 11 plus 4 lots of 12 plus 1 lot of 13 divided by, there are only 5 scores but they occurred more frequently than once each, and so it's divided by 11. Do you get it? Okay, don't know whether you've done much of this before. Now with this syllabus you are expected to calculate the measures of central tendencies, and there's 3 of them, without a calculator as well as with a calculator. Later on in the work we're going to just use technology to calculate statistics. Remembering we are here calculating a statistic, isn't it? It's a value we've calculated to describe some property of the sample that we've measured. Okay, so that's called a statistic when we do that calculation. So the first statistic that we're going to look at here to measure central tendency is the mean, and we've just had a look at it. Okay, so we'll come back and do some more with that. What's another one? Do you know another one? Okay, well here's one. I'll just bring this up here again from Pearson's now. The median is the number that divides the data in half when it's in order. So it's a middle score when you place them in order. At least half the data is equal to or smaller than the median. So the median is one of the scores. Okay, it's not adding them up and dividing by how many there were. It's actually one of the scores. So have you done this before? In a histogram, the median is that middle value that divides the histogram into 2 equal areas. That's sometimes hard to see. It's all right if it's symmetrical, as we looked at last time, but if it's skewed off to one side, it's hard to say where that middle value would be. So here's some values from a stock market index here. We've got 5 values, we place them in order. So it's easy to see with an odd number, n is odd. Here there's 5 scores, n is 5. The middle score is the third score, so you can see it's quite clearly in the middle, so that's the median. Okay, what if you had 6 scores? N is even down here. How are you going to find n is 6? How are you going to find the middle score? No score is actually in the middle. The middle is halfway between, so the median is halfway between those 2 scores there. So you'll find the average of them, or the mean of them. Okay, so the position of the median is given by n plus 1 on 2. Okay, now if n plus 1 on 2, let's do it for 6. 6 plus 1 on 2 is 3.5. So you'll average the 2 below it, the third and the fourth. The third and the fourth divided by 2. So the average. Remember, the median is the actual score. It's a position in the ranking of scores to show you the middle that way, without actually taking account of the size of the scores. Now, you'll start to think, well, I might like to add them all up and divide by how many there are. I like the mean better because I'm actually getting up close and personal with the actual value of the score. There might be situations, though, where that might not give you the best measure of the centre. Okay, but anyway, we'll have a look at that. So can you remember this thing down here now? To find the middle score when they're placed in order, the number of the score you're looking at is a total number plus 1 divided by 2. If it's odd, it'll be an actual score. 5 plus 1 is 6 divided by 2 is the third score. But if it's even, this will be 3.5 or a fraction, so you take the 1 above it, the 1 below it, and below that number 3.5, the integer below it and above it, and average them. Okay, so let's have a look now at the final measure of central tendency, and the final one there is the mode. The mode now is the most common value occurring in the data, the most common value. And so we don't use this very often for this reason here, and that is that several data points being exactly the same is fairly rare. If the variable is discrete, like it's the number of times you actually get a 6 in rolling a die, then that could be just that value. Okay, but But if it's height or something like that, it's unlikely that the measurement's going to be exactly the same. Somebody might be 160 centimetres tall, but actually it might be measured with low precision. The next person might be 160.1. If you've rounded it off, they could both appear to be 160, but it would be unusual that data sets have points occurring more than once in actual fact. Okay, just depends on the nature of the data. So the mode is generally not used. We don't generally use the modal value. Okay, alright, so let's go down and have a look at what we're doing here. We're trying to measure something from a group of individuals. So we're down here, aren't we? Descriptive statistics. We're actually measuring the nature of a group from a population, and that's called a statistic. When we take a sample, S for sample and S for statistic, when we take a sample from the population and try to actually measure something about it and describe that group, it's called a statistic. So sample statistics, S and S. But if we actually are lucky enough to be able to measure the whole population, now this is unusual because usually populations are large, and let's say there's something like motors made for cars. You can't actually measure the lifetime of a motor because you'll wear it out and then there'll be nothing to sell. So you couldn't do that for every motor that was made. Not only would it be expensive in time and money, but it would be pointless because you're trying to say what's the average, let's say, lifetime of the motor. And to do that, you have to wear it out. So we rarely actually do this, measure directly the population, what's the word, parameter, P&P. A population, if you measure all individuals, the measure that you're calculating there, let's say the average or the mean, is called a parameter, population parameter. It's the actual value, isn't it? It's the value of all the individuals. And with means, in population, we use a mu, Greek letters usually, for the population's calculations, the population parameters. And down here, of course, the mean for a sample, the sample statistic, is given the symbol X bar, just to distinguish them. So this is the actual value of all members, and this is the statistical mean for the sample we've taken from the whole group. So remember that, population parameter, PP, sample statistics. Okay, so that's an easy way of remembering it. So these are important terms in statistics land. Alright, so here we are, summarised here from Pearson's. A statistic is a descriptive measure computed from a sample of data. That sounds very complicated. It's a calculation, yep, it's a measure to describe something about a group and from a sample of data. Okay, a parameter is a descriptive measure computed from an entire population. So if you like, X bar is an estimate, if you like, of mu. So when you take a sample, it's actually estimating what the real value would be if you took the whole population. Now this is going to be important later on in inferential statistics. At the moment we're just getting our head around some terms to describe what we're trying to do in describing statistics, in descriptive statistics. Okay, are you getting the hang of it? Let's have a look at what Pearson's got here, a little example here of which you've seen before from the index of the stock market here. We've got 5 scores, sample size n equals 5, and what is the average? Add them all up and divide by how many there are. Okay, and you must be able to do that, this is explicitly mentioned in the syllabus. You can use technology, but you must be able to do this with and without technology, these measures of central tendency. This is called the sample mean. A second measure of central tendency is the median, which we just talked about, and that's the example I use. So you have to put the data and put them in order, usually ascending order going up. And then there's 5 here. So n plus 1 on 2, 5 plus 1 on 2 is 3, therefore you want the third score. Get the hang of that now, the third score. Okay, let's have a look at summarising this now. So the arithmetic mean or average of a set of measurements is equal to the sum of the measurements divided by n. So you must know this one, and of course I've shown you the one earlier from the information booklet, and that uses sum of fi n here from I equals 1 to n. Okay, so that's a sample statistic, isn't it? When we take a sample of n from, here it is, from the population. If we took the whole population, let's say the population has a size big N, there's a lot more of them, it means add them all up and divide by how many there are. Okay, so that's all of them, where n is the population size. So this is a parameter, this is a statistic. Measure the whole population, here we are, it's called the population parameter. Measure a sample, it's called the sample statistic. Okay, so that's an important idea there. Yep, so n is the population size, we're measuring all the individuals, and therefore it's a parameter that we're calculating here. The mean is for all the individuals, population parameter, only for a group, sample statistics. Sample statistic. Okay, and here it's estimated, isn't it? Really, x bar, only taking a group, will be estimating the real parameter value mu. Alright, okay, let's keep going and see what you think here, because I want you to make a decision. Would you use x bar, the mean, to describe the centre of a distribution, a sample, or would you use the median? We've already said probably not the mode, because often data sets don't have a single value which occurs more often than others, and there could be some inaccuracies there anyway. So what would you choose, x bar or the median? Would you choose the mean or the median? Let's take an example. Here's a set of height scores from 25 people. So n is 25. And they've been put in order. Okay, let's calculate the mean. So add them all up. Okay, so let's do that. The sum from I equals 1 to 25 of xi, where x here is the height, and we're going to divide by n, which is 25. And if we do that, we get 171 centimetres. Okay, if we put them all in order, here it is here, yes, they are all in order, n plus 1 on 2 here would be 25 plus 1 on 2, which is 26 on 2, which is the 13th score. Let's go in. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. Right, well, hang on. This is the one then. The median is 167, the 13th score. So we've got a little bit of a difference here. 167 centimetres versus 171. And the mode is also 167 here. We're going to phase that out though, because that's not going to be very useful overall, for the reasons we mentioned before. Okay, so you've got 171 and 167. Have a look at the data set, and which of those scores do you think measures the centre of the set of data best? Okay, let's have a look. There they are. Now, where is this? 171 is here, and 167 is here. If you wanted to describe to people what the centre was, because that's what we're about here with descriptive statistics, we might use graphs. Now we're going to use a statistic to indicate to people a property of the distribution. The property that we're trying to indicate here about the distribution of scores, the spread and the nature of the set of scores, is the middle. Well, have a look. Which one do you think represents the middle of this data set best? I think you can see 167 does. Okay, why? Well, there's only, these scores here, 1, 2, 3, 4, 5, 6, 7, 8 scores that are anywhere near 171 or above. 171 sounds a bit high. Most of them are here and here, or the few high ones here. So if you gave the impression gave the figure 171 as a measure of the centre of this group, people would get the impression that by and large that was about the middle and then there's some above and some below. And that's not quite what you want to imply, is it? Okay, because 171 is actually in the top 2/3 there, if you like to think of it that way. Okay, so here's the question. What happened? Why is it sometimes not best to use the mean as a measure of the centre? Can you see what's happened? When we added up these scores, along with all the others, see how they're quite a lot higher. Okay, all those are quite a lot higher from the other bunch. And when you add them up and divide by 25, that's going to increase your total here by quite a bit. Okay, because they are what's called skewed high or skewed positively. It's skewed in the distribution. And so the mean does not resist that. The X bar is a non-resistant measure of the centre, non-resistant measure. It doesn't resist the effect of those skewed scores. So it's prone to coming a bit high or a bit low there. Okay, whereas the median is a resistant measure of centre. Okay, it's resisting the effect of that skewness. Why? Because it actually doesn't take account of the size of the scores. It just takes account of the number of them. So the number of scores here. Okay, so it's resisting being dragged up or down by that skewness. Do you get it? It's important if you're going to enjoy maths. Maths is fun. If you get up close and personal with it, that's important to actually try and reason that out rather than just have a rule which you follow blindly. Okay, so it looks like we might choose the median if there is skewness present in a distribution. Let's develop that a little bit with this diagram here. This is a diagram of a distribution of scores, so we'd be expecting frequency. We'll just screen clip this from Pearson's frequency, that one, and the score along here. Now this is a perfectly symmetrical or symmetric distribution, and of course therefore the middle is the mode, the peak value, and the mean, because you've got actually exactly the same number and size of scores above and below that point. It's perfectly balanced. Mean and median and mode all give the same value in a perfectly symmetric distribution. So does it matter what centre you would use for such a distribution? No. X bar's good and the median's good. Both of those are good in a symmetrical distribution. Let's have a look at what happens now when it's not symmetrical. What we just had a minute ago here was this, a positively skewed distribution. We had this bunch of heights here which were not the same as on the other side. So this symmetrical distribution should be about like that. What's disturbing it? This bunch hanging out up the top here. So we say it is, as from the last presentation, skewed to the right or skewed high, or positively skewed, because positive movement on a number line is to the right. And so the median has been moved a little bit perhaps because of the number of scores, but the mean will move quite a bit more because you actually add on these higher scores. You actually add them up. So the size of them, not just how many there are, which is the median, works on the number of scores. You're actually adding on the higher values, and so the mean has suffered quite a bit. And now we would say, that's a very questionable measure of the centre. Because look at the most frequent ones were back here. If you said to somebody this mean value here is an indication of the centre, it's not, a bit misleading, isn't it, in describing what's happening with this set of data. And similarly over here, negatively skewed. We've got a bunch of scores here which are disturbing the symmetry. This is disturbing the symmetry, and that's how you work out skewness. Skewness is relative to a symmetrical distribution. So if you say it's skewed, you say, what's disturbing the symmetry? It's on this side, so that's skewed low, or skewed to the left, or skewed negatively on the number line. Negative is that one on the number line. Okay, so what's going to happen when you add on all these lower scores? It's going to give a mean which is less than this value back here. The median may suffer a little bit on the number of scores because you're dragging the number of scores to the left. And so we're getting a bit of disturbance here if the distribution is not symmetrical. So just remember now, X bar is a non-resistant measure. It does not resist the effect of skewness, non-resistant measure of the centre. And the median is a resistant measure. So what that means is if there is skewness present, we would generally go for the median so that we don't get a disproportionate effect of a few high or a few low scores on giving our description of what the data set is centred around. It's a measure of central tendency, that's the idea. Okay, obviously if you had a graph to offer people as well, then they could see what was going on. But we're talking about just taking a calculated value, a statistic, from a sample to actually indicate something. So it's a very quick way of saying, hey, this is what the mean is, what the median is, and people automatically get an idea of the centre. And we don't want to be misleading in that. Okay, let's go on. And I don't know whether a question arose in your mind. Say, Huddy, how come we went from histograms to smooth curves? What's going on there? Well, let's investigate that. Let's say this is a set of data, and this is times taken to get to school. We've done this before. Taken to get to school. Okay. So you've done quite a bit of work here. There's quite some high frequencies here. You've measured quite a number of times and got these bundles of different groups of times here in our histogram set. What if you did it an infinite number of times? An infinite number. Well, this is not an infinite number, but your group size would be small group intervals like that. And the more times you did it, the more data points you got, the more groups you could have there, and they would be narrower. And if n tended to infinity, if you had an infinite number of scores there, these would be infinitely small. And see what we've done here? We've gone from the midpoint of each group and joined it up into a smooth curve. So if you kept going, n getting bigger and bigger, you actually produce no significant difference. There's an infinite number of points in between here. And you would get a data point everywhere between those. So that's the idea. So if you have a smooth curve, then it's suggesting you're talking about a very large number, or the population if it's got a large number in it. And it's what we're going to do later on in this course, talking about the area under the curve. We're going to use that notion in calculus to find areas under curves and things. So that's an interesting thing. If you think about that, and you just refine it so that you have more and more data points, therefore you're going to have smaller intervals. They're each going to have significant numbers in them, right? Remember how we did a histogram? We said groups of, well, they have 5 to 10 groups. Okay, so if you get lots and lots of points, you're going to have to spread those out, and here you have this smooth curve happening. So think about that. That's going to be important a little bit later in what we're going to be doing in inferential statistics and also in calculus. Okay, let's go on. and have a look at what technology has to offer. And here I'm again using the Casio for these, and Pearson's uses the TI, so you can have a look in there as well. So let's have a look at using technology to calculate statistics. Now, first of all, once you've turned the calculator on, could you highlight stat mode there, and you move around the screen with this button, highlight stat mode. And then what I've done here is entered in the list 1 there, because that will be highlighted when you first hit execute on stat mode. I've put in the 25 height scores that we had from before. Okay, and then what I've done here next is to just hit execute, and we get this window here. This window here, once you execute that list. And what you need to do now is to choose set. We want to set up what we want to do. So that's F6 here. So if you hit F6, we get this window over here, and we need to tell the calculator where our data is. So it's 1 there in list 1. There it is. It is one variable, isn't it? It's heights. We've done many measurements, but it's only one thing we're measuring, one variable, it's height. And is this right? Frequency of 1? Yes, it is. Okay. Now, if we had, as I said before, a table with frequencies here and score here, and 9 occurred once, 10 occurred 12 times, whatever, then this would be list 1, and our frequency wouldn't be 1 anymore, would it? So this in here, we would have to scroll down with a button till that was highlighted, and then hit list and put frequency list 2, telling the calculator. So keep this in mind, please. We're not doing it here, but with a frequency table, you put the score in list 1, and then don't forget to change that second line, one variable frequency, scroll down with the button and highlight list 2 there, or whatever list you're choosing to do. So keep that in mind. Okay, what happens then if you execute that? We're back to this window over here now, and what we want is to calculate one variable statistics. So we're going to go to F1 there, and there we have it, F1. X bar is 171.16, and it says here we've got more. Okay, so all sorts of things calculated here, which we're going to do later on. N is 25, just telling you, you can check there that you've entered that many scores. So here, with this arrow here, it's talking about scrolling down. So scroll down with this button, and we get to the next entry, minimum, Q1, median, there's the one we want, 167, Q3 maximum, and mode. Well, we're going to use these, this is called a 5-number summary here, where we divide the data up into the minimum value, the lower quarter of values, the median, the middle half, and middle halfway, the Q3, the upper quarter, and maximum. So you might have seen that before. We're going to use that in drawing a diagram called a box plot later on, the next presentation in fact. Then if we keep scrolling down with this button here, we get to the last bit here. So the mode is 167. How many modes are there? N is one mode, so it's the only score that stands out from the others, and it occurs with a frequency of 3. Now, sometimes you could have 2 or 3 modes, in other words, if a number of scores each occurred 3 times. So you couldn't distinguish between the 3 modes. And that's a disadvantage of using the mode as a measure of a central tendency. Here it's not a bad one because it lines up with a median and does in fact indicate, from what we see, reasonably the centre of the distribution of scores. Okay, are you happy with all of that? Okay, so you must be able to do that, but you must be able to, in this course, do it by hand. That's explicitly mentioned in the syllabus. Alright, let's come down and give you a go. So I've split the questions here from Pearson's because I wanted to look at measures of central tendency, and separately the next thing, measures of dispersion or spread. So here are the first 4 questions on measures of central tendency. So I'll pause presentation here, and we're going to show you the answers as usual underneath in a minute. Okay, there's the first 4 questions. Okay. And then we got 5 and 6. Okay. And then the others belong to the next section. So pause that, have a go, and let's have a look now at the solutions. Okay, so there's question 1 and 2. Check your calculations there. Must be able to do this by hand without a calculator, like in paper 1, for example. Let's go to question 3 and 4. Okay. Could you notice the formula there? Don't forget to multiply the frequencies by how many times they occur. So if you're doing that in with technology, list 1 and the number of times they occur, list 2 here. Okay, they've done it by hand, which you must be able to do, and then divide by the total sum of the frequencies. Okay, try to understand that bit. Let's go down. 5 and 6. Okay, and again, Pearson's here has used the TI, so you go back and do that on the Casio, which is equivalent sort of setup. Okay, have you had fun? Do you get the idea? We're describing this data set that we've gathered and what it means about the group of people that we have measured there. Okay, well, that's the end of this one, and we've got a couple more coming up, which is very interesting. We want to get a good picture of this data set without worrying people with lots of numbers. Okay, can we describe it very well? Okay, for now, it's cheers from me. Catch you in the next presentation.